In this video, we're going to take a look at the covariance of two random variables. So if y1 and y2 are random variables with means mu1 and mu2 respectively, then the covariance between them is defined as the expected value of the product of y1 minus its mean with y2 minus its mean. So the expected value of that product, that is the covariance. So that seems like maybe a strange thing to consider. All right, why would we be interested in this? Well, we're going to be interested in it because it gives a measure of the linear dependence between those two variables. Right? And so what kind of specific information can we glean about that linear dependence? Well, if we have a larger absolute value in the covariance, then we're going to have a greater linear dependence between the variables. If we don't think about the absolute value, if we look at the covariance itself, if we happen to have a covariance that is positive, that's greater than 0, then when we have a covariance that's greater than 0, this covariance that's greater than 0, it is going to indicate that y1 increases as y2 increases. And if we have a covariance that's negative, then y1 decreases as y2 increases. Right? So one, they are kind of positively correlated, and one, they are negatively correlated. If that covariance is close to 0, then we would say they are uncorrelated. There is no linear dependence between them. Now, when we say they're uncorrelated, we're thinking they're uncorrelated linearly. They could possibly still be correlated with some nonlinear relationship. There could be some nonlinear correlation that's happening there. That value of the covariance, it depends on the scale used to measure them. And so this covariance we can standardize, so we can have an idea if the covariance we happen to get, if it's, oh, this is a large covariance or this is a small covariance. And so what does it mean to have a large or small covariance? I don't know. And so it depends on what scale we're using. And so we can standardize that with the correlation coefficient rho. Right? So that's the Greek letter rho. It looks kind of like a P. And that correlation coefficient, we find the covariance between y1 and y2, and we divide those by the standard deviations of y1 and y2, respectively. Beautiful. All right, so then what can we say about that correlation coefficient? What are some properties for this correlation coefficient? This correlation coefficient, after we've standardized the covariance, that correlation coefficient, it will be between -1 and +1. If we get a +1, if that correlation coefficient is +1, then what this tells us is it tells us we actually have a perfect positive linear correlation. All of those points are lying on a straight line with a positive slope. And if we have a -1, then all of those points lie on a straight line with a negative slope. And if we get a covariance of 0, then there is no correlation. All right. So what else can we say? If y1 and y2 are random variables with means mu1 and mu2 respectively, then the covariance is the expected value of y1 minus mu times y2 minus mu2. And that expected value we can simplify. And how can we simplify that? Well, we could FOIL that out, and so we could say it is the expected value of y1, y2 minus mu1, y2 minus mu2, y1 plus mu1, mu2. But what do we know about expected value? Well, we know that when we take the expected value of a sum, it is the sum of the expected values. So we could write this as e of y1, y2 minus, so that mu1, that would just be a constant. So when we take the expected value of that constant, we can bring it out in front. So we have mu1 e of y2 minus mu2 e of y1 plus mu1 mu2. And we know that the expected value of y2, that is mu2. And the expected value of y1, that is mu1. And so here, mu1, mu2 will have, this will cancel with that mu1, mu2, and so we're left with just this. And so I'm going to write that in maybe two different ways here. So we have our expected value of the product of y1 and y2 minus the expected value of y1 times the expected value of y2. And that is our covariance. That expected value of y1 we might write as mu1. That expected value of y2 we might write as mu2. So you might see this in some slight other ways. But this last theorem says the covariance is the expected value of the product of y1 and y2 minus the product of the expected values of y1 and y2. All right. In our next video, we'll take a look at a couple examples of these things. We will see you guys there.